Adding and subtracting rational expressions. Our review problem here is asking the domain that. In order to do that, we need to know where 6x squared plus 37x plus 45 is equal to 0. No common factors there. It looks like this is going to be a fun factoring problem. So, get ourselves a good lot of space on this. 6x squared here, 45 there. 6 times 45 is 240 plus 30, that's 270. So we need numbers that multiply together to give us 270. And when we add them, they give us 37. Okay, so let's see. The factors of this are 27 and 10. So I've got 3 times 3 times 3 times 2 times 5. If I start playing with ways of putting those together, if I had 2 3s and a 2. All right, so 9, that makes an 18 and 15. We know that these are both going to be positive, but 18 plus 15 is not 37. 27 and 10 right there would do it if I was subtracting, or no, I'm adding, so that'll work. So a 27 and a 10 there, 27x and 10x. Common factor this way is a 3x, and this way is a 2x. That makes a 6x squared. This would have to be a plus 9 right there, and this would be a plus 5 to make that happen. So this factors into a 2x plus 9 and a 3x plus 5, which means 2x plus 9 cannot equal 0, and 3x plus 5 cannot equal 0, which means x will not be negative 9 halves or negative 5 thirds. That is the domain for that one. All right, if we're dividing here, expressed a little bit differently than we did before, we'll factor that numerator into an x times x plus 2. That denominator will factor into an x plus 3 and an x minus 1. You can show that on the side if you needed to. This is going to flip over and multiply, so the x squared minus x is an x times x minus 1 when I pull out a greatest common factor there. And this one factors into an x minus 3 and an x plus 2. Didn't ask me for my domain here, so let's see, do I have anything? I've got an x minus 1 cancels with the x minus 1 and the x plus 2 with the x plus 2, and I'm left with an x squared over x plus 3 times x minus 3, which is the same thing as x squared minus 9. So that's what I get from that division. Okay, adding these and identifying any values for which the expression is undefined, well, we can say right off the bat that it is undefined for x equals 7 and negative 4. This is where it is undefined. And if we're going to add, then on this side, the common denominator is going to be an x minus 7 times an x plus 4. So this side is missing the x minus 7. This side is missing the x plus 4. So x plus 4 times 4 gives me a 4x plus 16 on that side, plus 2 through the x minus 7 is a 2x minus 14, and that's all over x plus 4 times x minus 7. 4x plus 2x is a 6x. 16 minus 14 is a plus 2 over x plus 4 and x minus 7. Could pull a 2 out of that numerator. 2 times 3x plus 1 over x plus 4 and x minus 7 is the completely factored best answer that I can get there. For this one, my undefines, again, are any place that would make the denominator equal to 0, so that's -2, -3, or 4. My common denominator is going to have everything that's in the first denominator, the x plus 2 and the x plus 3, plus any new things that weren't in this one. This already has the x plus 3 accounted for, but doesn't have the x minus 4. So this first piece was missing the x minus 4, so I'm going to have to multiply by x minus 4 over x minus 4. If you're just trying to follow this without the audio, I'm sorry. X plus 2 over x plus 2, so that this has all three pieces, this has all three pieces. We adjust in the numerator. Now we're going to have to do the x minus 4 times the 3x plus 1. Give us a 3x squared. We get a minus 12x there, a plus x there, and a minus 4. Looks like 3x squared minus 11x minus 4. Plus x minus 1 times x plus 2 is x squared plus x minus 2. And so I've got a 3x squared plus an x squared, that's 4x squared. A minus 11x plus 1 more x is minus 10x's. Negative 4 minus 2 is negative 6 over the x plus 2, x plus 3, x minus 4. This excuse me, has a greatest common factor of 2. So 2 times 2x squared minus 5x minus 3. Looks like that might factor. Sorry about that. So if that factors, it would definitely be a 2x and an x. And if I had the minus 3 and a plus 1 there, I believe that would factor that way. It's not going to create something where things are going to cancel. I'm going to go ahead and get rid of my little factoring square here because it's going to be in the way. So this is a 2 times a 2x plus 1 times an x minus 3 over x plus 2 times x plus 3 times x minus 4. Undefined for those particular values, and that is what the answer looks like. Alright, if we're going to subtract these, now one extra little step here, we've got to factor these first. I don't want to just multiply them together because it might be more things than I need. I'll do my factoring on the side here. And so I believe this is going to be if I go minus there and plus there, that's going to give me, yep, that'll factor that one. And then over here, I'm hoping that I either have 2x plus 3 or an x minus 4. We'll see what we get. That looks like that's going to definitely have to be the 4 there with a minus and a plus like that. So the common denominator is going to have a 2x plus 3 and an x minus 4 and a 2x plus 1 and an x minus 4, but it already has the x minus 4. So this one was missing the 2x plus 1. This one was missing the 2x plus 3. So 5x distributed through 2x plus 1 is a 10x squared plus 5x. And then we're going to subtract 6x and also subtract 9, because that subtraction that's here has to apply to both of these things, and that makes it 6x plus 9. But when we're subtracting that, we'll get that. So that'll give me a 10x squared minus x minus 9 over 2x plus 3 times x minus 4 times 2x plus 1. Okay. That looks like it might factor as a 5x and a 2x. 18 and 5, 10x and a 1x. Yeah, if I made that a 10x, and that a 9, and that a 1. So minus there, plus there. So it does factor into a 10x plus 9 times x minus 1 over 2x plus 3 times x minus 4 times 2x plus 1. That is the answer. And we can say that x cannot be equal to, because of this piece right here, x cannot be negative 3 over 2. X cannot be positive 4, and it cannot be negative 1/2. So there's kind of the rest of that answer. Okay, completely factor the numerator and denominator of this. Okay, well that will give me an x minus 3 and x plus 2 when I factor that one. This one will give me an x plus 3 and an x minus 2. Okay. The graph of f from problem 6 is shown here. Mark the locations of the x-intercepts and draw in the asymptotes. So we have one x-intercept here at a negative 2 and one here at positive 3. Our vertical asymptotes to be here. This is at x equals negative 3. This vertical asymptote is right here at x equals positive 2. The vertical asymptotes seem to correspond to the things I would have said here, that if it asked me for the domain, I would say x could not equal negative 3 or positive 2, which meant an input of negative 3 would have no output, and an input of 2 would have no output. Okay, so the denominator gives me vertical asymptotes when I put a negative 2 or a 3 into the numerator, I get a 0 out, which forces this across the x-axis at that point. So my x-intercepts come from the numbers that make the numerator equal 0. Okay, so that's the conclusion that we were looking to draw there.